Let's have a look at something that is called primitive functions. It's actually like the derivative, but the inverse process. So we know how to find the derivative of some standard functions, and now we're going to kind of go backwards. If we have the derivative, we're going to find the function. And these are very useful when we're going to work with graphs and finding areas and arc lengths of function, etc. So we need to be able to find the primitive functions. Let's start with a couple of examples. Let's say that we have this function 2x. If I tell you that this is the derivative, what was the function? Well, we know that we can actually guess this one because it's pretty easy. It's x squared, right? Because if this is the function and we're going to find the derivative, what do? Well, the 2, we move it in front here, and it's 2 times x, and then decrease the exponent here by 1. So it's going to be 1 at the end. So if I do it down here, 2x to the power 1. But we're not going to write out the 1 because it doesn't really add anything to the function. X to the power 1 is the same as x. We're just going to write 2x. So this if this is the function, this is the derivative. If we say that this is the function f of x, we say that this is the primitive, or the primitive function. As you can see, we have a lowercase f for the function, and the primitive is with an uppercase. Okay, so let's start guessing some other primitive functions. If the function is 3x squared, what is the primitive of this? Well, we can easily see that it's going to be x3, because remember, when we find the derivative of x3, same procedure, 3 goes down here in front, perfect, there's a 3 here, and then we decrease the exponent by 1, so it's going to be a 2 up here. So that's it. If this was x3, then its derivative would be 3x2. Or now we're going to call this, if this is the function, the primitive function of f of x is this. Okay, so the primitive function of 3x2 is x3. Let's do one more example. F of x is equal to x3. What's the primitive function of x3? Okay, so we can see that since it's a 1 here, actually, but we don't write it out, it's a 2 here. The primitive has a 2 here. Here the function is 2, we have a 3 here. So 3, we have a 4. So probably the exponent is going to be x to the power of 4. But maybe this is not everything, because let's check the result if this is correct, because if we find the derivative of this, it should be this, right? So what do? We can just write down here, well, 4 goes in front, right? 4 times x, decrease 4 by 1, so it's going to be to the power of 3. This is not exactly what's here, so this 4, we have to do something about this 4. how can we do that? Well, if we divide this by 4, we'll get rid of the 4. So let's see if this is correct. Now, this what we think is the primitive function of this. Let's find the derivative of this and see if we get x3. So that's a way of checking the result. So what we would do, well, the 4 goes in front, 4x, and we already have divided by 4, right? And then we're going to decrease the exponent 4 by 1, and I'm going to write 3. Since we have 4 times x3 up here and divided by 4, we can just cross them out. Okay, so we are left with x3, x3, which is the function. So we know that this is the primitive of x3. So the only thing we had to kind of adjust was to divide by 4, so we get rid of the 4. Okay.